the lac Operon. You know, the elucidation of the lac Operon was also a result of a close association between a geneticist, François Jacob, and a biochemist, Jacques Monod. They were actually the first to elucidate a transcriptionally regulated system. In lac Operon, here, lac refers to lactose. A polycistronic structural gene is regulated by a common promoter and regulatory genes. Such an arrangement is, well, very common in bacteria, and is referred to as an operon. To name a few such examples, there's the lac operon, tropoperon, ara operon, his operon, val operon, and so on. The lac operon consists of one regulatory gene, the I gene. Here the term I does not refer to inducer. Rather, it is derived from the word inhibitor, and three structural genes, ZY and A. The I gene codes for the repressor of the lac operon. The Z gene codes for beta-galactosidase, or BGAL, which is primarily responsible for the hydrolysis of the disaccharide lactose into its monomeric units, galactose and glucose. The Y gene codes for permease, which increases the permeability of the cell to B-galactosides, and the A gene encodes a transacetylase. Hence, all the three gene products in a lac operon are required for metabolism of lactose. In most other operons as well, the genes present in the operon are needed together to function in the same or related metabolic pathway. Lactose is the substrate for the enzyme beta-galactosidase, and it regulates switching on and off of the operon. Hence, it is termed as inducer. In the absence of a preferred carbon source such as glucose, if lactose is provided in the growth medium of the bacteria, the lactose is transported into the cells through the action of permease. Remember, a very low level of expression of lac operon has to be present in the cell all the time. Otherwise, lactose cannot enter the cells. The lactose then induces the operon in the following manner. The repressor of the operon is synthesized all the time, constitutively, from the I gene. The repressor protein binds to the operator region of the operon and prevents RNA polymerase from transcribing the operon. In the presence of an inducer, such as lactose or allolactose, the repressor is inactivated by interaction with the inducer. This allows RNA polymerase access to the promoter, and transcription proceeds. Essentially, regulation of lac operon can also be visualized as regulation of enzyme synthesis by its substrate. Remember, glucose or galactose cannot act as inducers for lac operon. Can you think for how long the lac operon would be expressed in the presence of lactose? Regulation of lac operon by repressor is referred to as negative regulation. Lac operon is under control of positive regulation as well, but it is beyond the scope of discussion at this level.